So we have studied basic concepts of matrices. We defined some basic operations on matrices. Matrices have many applications, and in today's lecture we shall talk about one application of these matrices, that is utilization of matrices to find solution of linear system of equations. What do we mean by solution of an equation? For example, if we have this equation 3x is equal to 6, by finding the solution to this equation, we might mean finding the value of this variable x such that this equation is satisfied. So solution of this equation is quite easy. X equal to 2 satisfies this equation. 3 multiplied by 2 will be equal to 6, that is left hand side is equal to right hand side. Similarly, if we have equations in two variables, for example, if we want to solve this equation, x plus y is equal to 1, x minus y is equal to 0. We have two equations in two variables. Solution to these equations, you know the procedure. From one equation, for example, from one equation, if we bring y to the other side, we have this one, and if we substitute x equal to y into the first equation, then we have 2x is equal to 1, which implies that x is equal to 1 by 2, and from this equation y is also equal to 1 by 2. So this is the solution to this equation, right? So over here the situation was simple. We had two equations and two unknowns. In many cases we shall have more number of variables and more equations, and the procedure to this procedure to solve the equation becomes a little bit difficult, and we shall learn a procedure which is more systematic and easier. Remember that in this particular case, the solution, we were able to find the solution. However, there may be situations when you are not able to find the solution to system of equation, or when no solution exists to system of equations. For example, if we have this equation, let's say, so we have another system of equations, and if we, for example, again find by substitution we have 0 equal to 1, so there is no value of x and y which satisfies this system of equation. So we say that no solution exists to this system of equation. We can more easily explain it graphically. If I plot this on a graph, the equation of a straight line, what is graph of that line? If horizontal axis is x and vertical axis is y, then x plus y equal to 1, you are more convenient with this form, y is equal to minus x plus 1, that is bring the x to the right hand side. So this is an equation with slope of minus 1 and an intercept equal to 1. So this is the graphical representation of the first equation. The graphical representation for the second equation is this one, x is equal to y. So this intersection point, this is the point which satisfies both the equations, and therefore this is the solution to this equation. If we look at this equation, these two equations, the plot of these two equations looks like this one. For this equation, it is the same as this one, so this graph, and for this equation we have this graph which passes through the origin, right? So there is no common point, there is no point in the two-dimensional space which satisfies both the equations, therefore no solution exists to this equation. There may be cases when here there was only one point which satisfied both the equation, and that was our solution. There may be cases when multiple points satisfy both the equations. For example, if you have this equation x plus y equal to 1 and 2x plus 2y equal to 2, so the graph of these two equations, here is the x-axis, y-axis. This is graph for the first equation, and here is the graph for the second equation. Both the graphs overlap, therefore there are multiple points, to be more precise infinite points, which satisfy both the equations. Therefore there are infinitely many solutions to the system of equations. So in general we have more equations, and these equations can be in general written as, so over here we have m equations and there are n unknowns. In today's lecture we shall address three questions. First of all, whether solution exists or not. So does the solution exist for this general system of linear equations? We shall talk about these questions. First question is, does the solution exist? For example, we can have situation when no solution exists. The second question, is the solution unique? We may have a unique solution, for example this case, or we may have infinitely many solutions as it was this case. And the third question that we shall address is that how to find the solution. If solution exists, how to find the solution. So we start with the third question rather than with the first question, and we utilize matrices to solve this system of linear equations. For that purpose, the first step is to write the system of equations utilizing matrices. If we multiply these matrices, we again get the same system of equations. That is a11 multiplied by x1 plus a12 multiplied by x2 up to a1n multiplied by xn. This becomes the first row, that is equal to b1. This is the first equation. Similarly, the second row determines the second equation, and so on. So the procedure to get the solution to this system of equation is called Gauss elimination. With this approach, what we do is, first we construct a matrix which is called augmented matrix, and from here we construct this matrix which has the same coefficients which were there in this matrix, augmented with this right hand side. Because this vector is always obvious, we have x unknowns, we have n unknowns, so we can just omit this to ease our writing of these matrices. So this matrix, and then the right hand side is b1, b2 up to bm. This matrix is called augmented matrix. So once we have this augmented matrix, we reduce this augmented matrix into triangular form. How do we reduce it into triangular form? We shall talk about it. But once we have triangular form, then we can obtain solution by substitution. So this matrix is called augmented matrix. We have talked how to construct this augmented matrix, and then we reduce this augmented matrix into triangular form. How to reduce it into triangular form, we shall talk about it, and then we perform back substitution. Generally it is more difficult to understand general cases, so let's elaborate these points with the help of specific examples. We have this system of equations and we want to solve it using matrices. So we have x. So now we know how to write this system of equations into this matrix form, and then how to obtain the augmented matrix. So to construct this augmented matrix, we write the coefficients. This is the augmented matrix, and by a procedure which we shall learn, we transform it into a triangular form. That procedure is called row operations. We shall also talk about row operations. However, by row operations, we transform it into a triangular form. So for this system of equations, we have constructed an augmented matrix, and by an operation which is called elementary row operations, which we shall study, we have transformed this augmented matrix into this triangular form. Once we have this triangular form, then we can use back substitution to obtain the solution to this system of equations. What is back substitution? From this third row, we can construct the equation minus 95 x3, that is equal to minus 190, and from here x3 comes out to be 190 divided by 95, which is equal to 2. This negative sign is cancelled out with this negative sign. From this equation, the second row, we have 10x2 plus 25x3, and x3 we have found it, that is 2, and the right hand side is equal to 90, which implies that what is x2? So here is 50, 90 minus 50 is 40, 40 divided by 10 is 4. And from the first row, we have x1 minus x2, we have already found x2 plus x1 plus x3, that is equal to 0, and from here we have the solution x1 equal to 2. So that is the solution to this system of equations. What is the procedure? We had system of equations, we constructed the augmented matrix, performed some operations which we shall learn called the elementary row operations to transform this matrix into triangular form. Once we have triangular form, then finding the solution is quite easy. We can use back substitution approach to find the solution. So over here, what we have talked about is that once we have this triangular form, then we can use back substitution to find the solution. Now the question is how to find the triangular form. So to obtain a triangular form, we can perform elementary row operations. So here are the elementary row operations. If you interchange two rows of this augmented matrix, that will not change the solution. That is intuitive. If I write this equation over here or over here, that will not change the solution. So interchanging any row with another row of this augmented matrix, it will not change the solution. That is quite intuitive. If you multiply one row with a constant and add it to another row, that does not change the solution, right? Basically, this is the procedure that you have already learned in your previous studies. That is, for example, if you had this equation x plus y equal to 1 and x minus y equal to 0, what you had done is you add this row, this equation with the first equation to get another equation. So that does not change the solution. So this is row, if you add a constant multiple of one row to another row, that does not change the solution. Therefore, this elementary row operation will not change the solution. If you multiply a row with non-zero constant, that also does not change the solution. This constant must be non-zero, otherwise you will lose the information that is contained in that equation. For example, if I multiply this equation with 0, then whatever information is contained in this equation will be lost. Otherwise, you can multiply it by any constant, whether positive or negative, that will not change the solution to system of equations. So you can perform these elementary row operations to transform this augmented matrix into triangular form. Let's apply these elementary row operations to this matrix to transform it into the triangular form. How we can proceed? This triangular form is also called echelon form. How to transform this augmented matrix into echelon form? By performing the elementary row operations. We can add these two rows. First row, and we can multiply first row with 1 and add it to the second row. That is allowed. We can do it without changing the solution. Here this symbol is used to denote that both the matrices are equivalent. That is, both the matrices are row equivalent and will have the same solution. So we have multiplied row 1 with 1 and added it to row 2. So what do we get? 0. 1 plus 1 is 0, minus 1 plus, so 0, 0, 0. We get this equation. And then let's write the equations, rest of the equations as it is. Even we can do it in a single step. Here we can multiply first row with 20 and subtract it from the third row. That is row 3 minus 20, row 4, right. Row 4 minus 20 multiplied by row 1. So what do we get? Is it correct? We have multiplied row 1 with minus 20 and added it with row 4. So what we can do next? We can multiply this row with 3 and subtract it from here. That is allowed. That will not alter the solution. So there was a question and we shall also talk about that question in next lecture in more details. If you have here we had written general system of linear equations. Over there were m equations and n unknowns. So if you have more equations than the number of unknowns, that situation is called overdetermined. What will be consequences of these things? We shall also see it in the next lecture. However, if you have more number of equations than the number of unknowns, this is called overdetermined, as it was the case over here. We had 3 unknowns and 4 equations. Number of equations is more than number of unknowns. Therefore, this was an overdetermined system of linear equations. And then we have, this is the case when m is greater than n, then determined when the number of equations is equal to number of unknowns, and then underdetermined. What is underdetermined? When the number of equations will be less than the number of unknowns, then that situation will be called underdetermined. Then we have, if we are able to find solution to system of equations, that system of equation is called consistent systems. That is, if we are able to find the solution to system of equations, that system is called consistent system. Here this system is a consistent system. And then what is inconsistent solution? Inconsistent system. If you are not able to find, if solution does not exist, then that system of equation is called inconsistent system of equation. The example is, we have already talked about the example. For example, x plus y equal to 1 and x plus y equal to 0. No solution existed for this particular system of equation. Therefore, this system of equation was inconsistent. So we shall continue this discussion in the next lecture, inshallah. Any question up to this point?